Doc here. Okay, I'm going to try to get a little better at when I switch the slides, it starts over the recording. So sometimes I'm still talking as I'm clicking the button. So I'm going to try to be more conscientious of that. Okay, so solving equations. Now, again, I'm going to say keep in mind, Chapter 1 is a review of all the high school you should have had, or all the math you should have had in high school. And so if there's things there that you don't recognize or something there that you do recognize but you're not really strong in, that's when you need to take note and go find some resources to help you strengthen those areas. All right, so we're going to do linear, quadratic, and other types of equations today. Okay, so the values unknown that make the equation true are called the solutions or the roots, and we're going to be solving the equations. Two equations have the same solutions are called equivalent equations. Some things that help us to solve equations is that we can add the same thing to both sides of an equation and it doesn't change the value. And we can multiply both sides of the equation and it doesn't change, I should say, it doesn't change the fact that they're equal. So linear equations, there I did it again, I clicked before I was finished talking. Linear equation, ax plus b equals 0 form. Okay, so if you have an x to the first power, then you have a linear equation. If you have x to another power other than 1, it's not linear. Or the square root of x, which is a power of 1/2. Or if you have x to the negative power, which would mean it's on the bottom of a fraction, not a linear equation. Okay, so here we have 7x minus 4, 3x plus 8. We see that x to the first is the highest exponent on both sides. We are going to add 4 to each side. Now, I could have subtracted 8 from each side as well, but we decided to add 4 to both sides in this problem. That will give us now 7x equals 3x plus 12. So we will subtract the 3x to move it over to this side. And now I'm down to 4x equals 12. So I will divide both sides by 4 or multiplying by 1/4, which is the same thing. And I will find that x equals 3. Checking your answers. If I put 3 into the left-hand side and 3 into the right-hand side, that's what this means. Left-hand side, right-hand side of the equation. I will get 17 on both sides. So since that's a true statement, that 17 equals 17. The left-hand side will equal the right-hand side. It's important to check your equations, even more so important in the nonlinear equations. Quadratic equations. Quadratic equation means that the highest exponent would be a 2. So the degree of the polynomial would be 2. Zero product property means that if A is 0 or B is 0, 0 times anything is 0. Here we have an equation that's quadratic. First thing I want to do is I want to take 24 from this side over to this side, and I will do that by subtracting 24 from each side, and now I will get this. I want to see if this factors, so I ask factors of 24 that I subtract to get 5, and it's a positive 5, so that would be a positive 8 minus 3. Now I can set both of those factors equal to 0 and solve them. And I find that x will equal 3 and x will equal -8. I want to check my answers, so I'm going to substitute 3 in to see if I get the right-hand side equal to the left-hand side. And I will also check -8, and both of those do work. Solving a simple quadratic equation, that would be something like this, where we just have x squared equals 5 or x squared equals anything. So I could take the square root of both sides and solve this right away. Same over here, because these are in parentheses, x minus 4 is in parentheses squared. I could take the square root of both sides here as well. So, as I said before, and I'm going to demonstrate this a little better because they do kind of jump over it. If I have x squared equaling 5, I can take the square root of this side and the square root of this side. The square root of x squared is just x, and the square root of a number would be plus or minus. If it doesn't break down, you're going to leave it under the square root sign. Second one, the same. I'm going to want to take the square root of both sides here. When I do that, I will then get x minus 4 equals square root of 5 and I want to emphasize here that this is still plus or minus. We can put that in now, or we can wait to the next step. And I will add 4 to both sides. And when I do that, I will now have x equals 4 plus or minus the square root of 5. And that doesn't break down any further, so you leave it like that. So you have two answers here. See, 4 plus the square root of 5 and 4 minus the square root of 5. Okay, they're showing you again. Add 4 to both sides. And now we need to check them. Ooh, they didn't show the check. So I'm kind of surprised. But yeah, you should go back and check those into your equations to make sure that they were correct. All right, so now we can see another example. You can also solve a quadratic equation by a method called completing the square. And this is one of those methods that's really important to learn because you will use it in a lot of different areas. You'll use it for graphing and for figuring out transformations. So very important that you learn how to solve by using a difference of squares. I will explain this more in the next slide. Okay, so here we have equation and we want to solve it by using a difference of squares. The first thing that I'm going to do is take this and toss it over to the other side. So I have x squared minus 8x and when I take that 13 to the other side, I will get negative 13. So that's the first thing that we're going to want to do to both of these. Oh, let's see. Let's go to the next. Okay. Take the 13 over to this side. We'll look at this one secondly. Let me erase that mark up there so those of you that bothers, I can have it out of the way. All right, now, here's the kicker part. And here is where we want to take a look at what we would add to both sides. And in this case, we're adding 16 to both sides. But how did I get that? I take this middle number right here, -8. Whatever that middle number is, I divide it by 2. So I always divide by 2. And then I will always square it. And you notice it's a negative, but when you square a negative, you'll get a positive. So this becomes -4 squared, which is 16. And that's how you get the 16 on both sides. Now we're going to simplify that. And we're going to make the binomial square x minus 4 quantity squared. And we have 3 remaining on the other side when I add my numbers. Now I have a problem just like I had before. So I can take the square root of both sides. And I get plus or minus the square root of 3. Move the 4 to the other side. And I get 4 plus or minus the square root of 3. Okay. Now, this one's a little more tricky. Here I have a number in front of the x squared, so that changes things a little bit. I want to bring my 6 over to the other side like I did before. But this time I'm going to factor the 3 out of both of these so that I can have x squared here. So when I do that, I'm actually going to have 3 times x squared minus 4x and then I'm going to add something right here to finish completing the square. And whatever I add to there, I have to remember that I have to add the same value to the other side. So, sorry, my negative on the 6 there got a little crazy. So I'm going to divide my -4. Again, you divide this right here by 2. So I now have -4 divided by 2. And then I'm squaring it. So -4 divided by 2 is -2, squared is 4. So that means I'm going to add 4 to this side. But notice I actually have a 3 in front of here. So I'm actually not just adding 4, I'm adding 12. So I have to add that total 12 to the other side as well. Okay, so that's what they just explained to you there, that you have to add 12. And so now we can complete the square. And they just put 3 times 4 here. They should just put 12. So now when I complete the square, I have 3. And I have x. There's a minus sign in my binomial square. So this is going to be -2 quantity squared equals -6 plus 12 is +6. Okay, now I want to continue, so I'm going to divide both sides by 3, and I will get x minus 2 quantity squared equals 2. And now I'm going to continue by taking the square root of both sides, and I'll get x minus 2 equals plus or minus the square root of 2, and move the 2 over to the other side. So that's the completing the square method, and it might seem a little more difficult than the next thing that we're going to talk about. However, completing the square is, again, a method that you will use in other areas of math that's handy, so it's good to know. Now, here's my favorite. Quadratic formula. Quadratic formula will solve any quadratic equation, and you can learn it by singing a little song. So, if you see, this is x equals negative b plus or minus the square root of b squared minus 4ac over 2a. If you use the song, say Pop Goes a Weasel, and sing it that way, then you go x equals negative b plus or minus the square root b squared minus 4ac all over 2a. I'm going to say that again. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. Best way to remember the quadratic formula, I'm telling you. Practice it. Practice it in private if you don't want anyone hearing you sing math songs. Okay, let's look at using it. All right, so whenever I use the quadratic formula, whatever's with the x squared is my a, whatever is with my b term, or whatever is with my x term is my b, and my constant is my c. And as always, we are taking the sign in front of the number. So this would be 3, this would be negative 5, and this would be negative 1. Three, negative 5, and negative 1. Then we're going to take those values and plug them into our quadratic formula. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. And then simplify. Here we go. Now, sometimes they like to separate it and write it like this, like 5, 6, plus or minus square root of 37 over 6. So you'll see it both ways. Now you can use a calculator to get the exact, or not the exact, but the approximate number, because we have a square root of a prime number there, so we know that it's going to be irrational. And there are your two answers. And you should go back in your equation and check them. All right, B. A is 4, B is 12, and C is 9. So once again, x equals negative b plus or minus the square root b squared minus 4ac all over 2a. Simplify. That worked out nice. and I get negative 3 over 2. Now we're going to look at the fact that this was 0 and very soon. So it only has one answer here, because plus or minus 0 added to that answer is not going to make a difference. All right, thirdly, here's my A, my B, and my C for my third equation. So again, x equals negative b plus or minus the square root b squared minus 4ac all over 2a. Now notice they didn't put the 1 in here for 4ac, but that's because they know that if you just multiply it by 1, that it's not going to change anything, but should have probably put it in there. All right, so here we have negative 2 plus or minus the square root of negative 4 over 2. So now we have negative 2 plus or minus 2 square roots of negative 1. So we have negative 1 plus or minus the square root of negative 1. Now, if we're doing the answers in a real number system, negative 1 is not a real number. Square root of negative 1, not negative 1. Square root of negative 1. So this would have no real solutions. So this next slide is going into that further to tell you that sometimes you'll need to double check whether or not you're going to have two answers, whether you're going to have just one answer, or whether you're going to have no answers. And you can figure that out by using the part of the quadratic formula that is underneath the square root. So when I say x equals negative b plus or minus the square root of what? B squared minus 4ac. So if you just look at b squared minus 4ac, that's going to be what's underneath that square root. If it's bigger than 0, you're going to have two answers. If it's equal to 0, you'll only have one answer. And if it is less than 0, you're not going to have any real numbers because the square root of a negative is not a real number. So this is a check for you to take a look at whether you're going to have 2, 1, or no real number answers. So here, they're not telling you to solve. They're just saying, just tell me whether there'll be 2, 1, or no answers. So we're going to look at the first one, and we have A being 1, or B being positive 4, and C being negative 1. So the discriminant, which is B squared minus 4AC, is 20. And 20 is bigger than 0, so that tells me that when I do figure out what this answer is, I'm going to find out that it has two real number answers. The second one, the discriminant is 0, so it's only going to have one real number answer. So here we have my b squared minus 4ac. So this is my ABC up here. B squared minus 4ac is 0. So one real solution answer. Here in the third one, b squared minus 4ac gives me negative 4/3, and that's smaller than 0. So this one has no real solution. Now again, we did not find out any of the solutions. We just found out what kind of answers they would have by checking a discriminant. And this is something that you can do before or while you are using a quadratic formula, either way, to help give you an idea of if your answer is correct or not. All right, well, there are other types of equations besides linear and quadratic. Here we have 3 over x plus 5 over x plus 2 equals 2. And you see the x's are on the bottom of the fraction, which means they're actually to the negative power. So we can multiply both sides, or multiply both sides of the equation by the common denominator. So if I look here and I say, what is my LCD? What is my common denominator? My LCD, lowest common denominator, or least common denominator, is going to be X, ooh, that's a big X, times X plus 2. Okay, so there it is on both sides. And when I do that, I will get rid of my rational expressions. And now I can simplify by distributing through the 3 and then combining like terms. Getting all of the terms on one side so I can set it equal to 0. And I can also reduce it by dividing everything by 2. And that factors. So since it factors, I find that I get x equals 3 or x equals 1. Now, it's important to note that you need to check your answers, especially when you have rational equations. If I check 3, I will get 2 on the left and 2 on the right. So that works. If I check -1, I will get 2 on the left and 2 on the right. So it also works, but that's not always going to happen. All right, let's look at an equation involving a radical. First, I want to get this radical by itself. So I have right here is my radical. I want to get it by itself. And sometimes people like to move this by dividing everything by -1 first also. You can if you want to, but you don't have to. Because what you can do at this point is you're going to square this side. And whatever you do to one side, to keep everything balanced, you have to do to the other. So that's how we get this step. Now this is a binomial square, so I'm going to multiply it out. And then I'm going to combine like terms. Okay, I combine like terms here. Factor. Set them equal to 0. And I have my 2 answers. Now we have to check our answers. And when we do check our answers, we see that the -1/4 does work. But the x equals 1 does not work. So there's only one solution. So if you don't check your answers, especially when you have rational expressions, you could be making a big mistake. Here it shows you that the left-hand side is going to equal the right-hand side. But for x equals 1, the left-hand side will be 2. The right-hand side will be 0. So since they're not equal, x equals 1 is not a solution. And that's where this symbol comes in. which means not equal to. So if we end up with one or more extraneous solutions, so possible solutions that don't work, that can happen sometimes. In example 11, the value x equals 1 is an extraneous solution. Okay, so we need to remember that when we are squaring each side of an equation, because the operation of squaring can turn a false equation into a true one. Fourth degree. Here, it kind of works out nice because I have 4, 2, and then 0. If you remember, when we have a quadratic equation, we have x squared, then we have an x term, and then we have an x to the 0 term, which is just 1. And in this problem, that would be what would be in front of or after the 8. So I always call this a 2, 1, 0. You can multiply 2, 1, 0 by any number, and you can still work with it as a quadratic equation. What do I mean? Well, if I take 2, 1, 0, and I multiply it by 2, I'll get a 4, 2, 0. And that's what I have here, 4, 2, 0. So if I rewrite it like this, I could still have it looking like a quadratic equation. So I can substitute w in for x squared, use the quadratic formula. Remember that w is equal to x squared, so now I set it to x squared. And then I'm going to take the square root of both sides again, and when I do, that is how I'll get my answer. So there are 4 solutions. There is 4 plus 2 square root of 2 under the square root, the square root of 4 minus 2 square root of 2, negative square root of 4 plus 2 square root of 2, negative 4 minus square root of 4 minus 2 square root of 2. And if we put them in the calculator, we can get close approximations.